Welcome to this class. Today I am continuing the chapter Wave of the subject Science and Technology of class 10, and it is taken in the unit number 10. We have divided this Wave chapter into different 11 parts and we are presenting one after another. This is fifth part of the chapter Wave. And in this part, we are going to focus on dispersion of light. Dispersion of light, exactly what is it, how it occurs, what is the reason behind dispersion of light, etc. we'll discuss in this class. Okay, I want to tell you one interesting matter. I think you have seen the rainbow in the sky. Whenever there is rain, after the rain, if sun is behind and rainbow appears in front of the sun, I mean to say opposite of the sun. Yes, you have observed this. It has 7 different colored light. Rainbow consists of 7 different colored light. You have noticed this. And somewhere, probably you have seen the bubbles, soapy bubbles, which is a little colorful. This is also actually colorful rays of light. And this occurs because of the dispersion of light. The same thing we are going to study today. I want to start with the help of a diagram. Let's have a prism. Look at this prism. Really it appears like this. This is triangular prism and it is made up of glass. We are using this prism for the dispersion of light. If a prism is taken and a cardboard is taken and a hole is made in the middle of the cardboard, and if we pass white light through this cardboard, then certainly white light enters through the hole, and it when falls on the prism, what is found? It divides into 7 different colors. At one edge we'll have red color, at another edge we have violet color, and remaining 5 color also seen in between red and violet. This way, when white light enters into prism, it divides into 7 different colored light. And this process is actually dispersion, and this practical we can do in a dark room. And we must have a room which is dark, and then only we'll be able to see all these 7 different colors. This process is called dispersion of light. And when this ray comes out from the another surface of the prism, it can be made to fall on the screen this way. In this surface, actually at this surface, refraction takes place. This is dispersion because white light is splitting up into different 7 colored light, and this is refraction, in which only the bending of light occurs, and they are separated well and can be observed nicely on the screen. And this color band which appears on the screen is called spectrum. Let's try to remember different 7 colored light which appears in the screen, which is called spectrum. What are they? They are in the order of V, I, B, G, Y, O, R. We have to remember this word VIBGYOR from bottom to the top. V means violet colored light, I is indigo, B means blue, G is green, Y is yellow, and O is orange, and R is red. It means white light contains these 7 different colored light. It is composed of these 7 colored light. This is proved by this process also. That's why this is dispersion, and I want to define this dispersion now. The process of splitting up of white sunlight into 7 different colored light is called dispersion of light. This way we can define dispersion. In the same way, what is spectrum? Spectrum means the color band of light of 7 different colors obtained on the screen after the dispersion of light is called spectrum of white light. Isn't it? Now let's have the same diagram. Now, what is the reason of dispersion of light? Why this white light separates into 7 different colored light. What is the reason why light disperses into 7 different colored light? I want to explain about this. Actually what happens, someone in previous class I told you that when light enters from one medium to another medium, then its velocity changes. If it enters from rarer to denser medium, its velocity decreases, and if it enters from denser to rarer medium, its velocity increases. Because of this increase and decrease of velocity, light bends in second medium. Same thing is happening here. But here a little difference is white light contains 7 different colored light. When it enters into prism, glass of the prism, then the amount of decrease of velocity of light become different for 7 different colored light. This velocity of one of the colored light decreases a little, another decreases a lot. Because of the amount of decrease of velocity is different for different colored light, that's why they separate from each other, their bending becomes different and they appears in 7 different color, that is called a spectrum. This is the reason the amount of decrease of velocity is different for each of the colored ray of light. Okay, now we can write this way also. Let's have the short reasoning. Velocity of 7 different colored light contained in white light reduces when it enters into prism. But the amount of decrease in velocity is different for different colored light. Hence, they separate from each other and dispersion occurs. This is the reason of dispersion. It's very simple, very clear. But the question is, why red bend a little but violet bends a lot? What the reason of bending of violet is a lot and reason of bending of red is less? We can answer this way. This table is given in your book also. This is the table of different colored light and its wavelength. The wavelength of red colored light is very long in comparison with other. It ranges from 6.2 to 7.8 into 10 to the power minus 7 meter. It ranges in this range, but in case of violet, its wavelength is very short in comparison with this red. It ranges from 3.8 to 4.4 into 10 to the power minus 7 meter. Since the wavelength of red colored light is more than that of the violet colored light, so when it enters into glass, if a ray of light has long wavelength, then it bends less. If a ray of light has short wavelength, then it bends more. So red bends less, but violet bends a lot. That's why we can answer this way also. Shortly, bending of colored light depends upon wavelength. Greater the wavelength, the decrease of velocity is less, and vice versa. Velocity of red light decreases less because of greater wavelength, but the velocity of violet light decreases a lot because of less wavelength. If decrease of velocity is less, then bending will be less, and if decrease of velocity is more, then bending will be more. So, red colored light bends less, but the violet colored light bends more. Okay, in the meantime, I want to tell you one interesting matter also. Let's have one question. Do you think that sunlight is white in color? We are saying white sunlight. Many times I told you white sunlight. In your book also it is written white sunlight. Do you think sunlight is white? Exactly not. Sunlight is not white, even though we used to say that sunlight is white. And it is traditionally told in science that sunlight is white and it contains 7 different colored light. But actually, it is not white in color, it is transparent. Now, second point, very interesting. Light itself is not visible. Do you think light is visible? Light travels from one place to another place, At the at the space of travel, if we see light, we will not be able to see the light. Light travels from one place to another place, but light cannot be seen when it falls on a body and reflected by that body and comes to our eye. Then only we will be able to see that object, that body. It means light itself is not visible, but it makes the objects visible. We have to remember this. Okay, now let's come back to our point. White light is made up of 7 different colored light. First, when it was told by the scientist, people had very confusion. They told that, is this true? White light contains 7 different colored light. It cannot be seen anywhere. Sunlight is transparent and it cannot be seen. I mean to say 7 different color cannot be seen just in the case of rainbow only, just in the case of some of the bubbles, soapy bubbles only, a little colorful appearance seen. It means they had confusion, and this question was raised that maybe white light is not composed of 7 different colored light. For the first time, Newton made a color disk to prove that actually white light is made up of 7 different colored light. And we are going to talk about this Newton's disk. This is actually a circular cardboard or metallic disc. We can make the discs made by cardboard also or metal also. It is a circular cardboard or metallic disc which is painted with 7 different colors in unequal sectors in the order of color of solar spectrum, that is violet, indigo, blue, green, yellow, orange and red. It means this is a circular disc and it is painted with color. And which color is painted? The color present in white light is painted in the order of VIVGYOR, VIVGYOR. But do you know that the area of the color sector depends upon the intensity of colored light present in the sunlight? All the sector should not be equal. I mean to say the equal sector is not painted with all these 7 colors. According to the intensity of this colored light present in the sunlight, the area is painted differently. Maybe one has a little more area and another has a little less area. The area of the colored sector is different in this Newton's color disk. And it depends upon the intensity of light present in white light or sunlight. Okay, it appears like this. This diagram is given in your book also, that's why I am showing this diagram. And how this Newton's color disk proves that sunlight is made up of 7 different colored light. When we rotate this Newton's disk very fast, when it is rotated faster, then it appears like this, means somewhat white, a little grayish white. What is the reason? It proves that this sunlight is made up of 7 different colored light. Now what is the explanation behind this? When this Newton's colored disk is rotated, then it appears white. It means this sunlight is made up of 7 different colored light. What is the explanation behind this? I want to explain this a little nicely. Do you know that if an object remains in front of you up to 1/16 second to 1/20 second, then only it becomes visible to you. If an object remains in front of you for 1/16 second to 1/20 second, then you will be able to see that. But if an object moves very fast from your eyesight, then you will not be able to see that object. If it is faster than 1/20 second, 1/20 second means 1 part of 20 seconds. I mean to say, if 1 second is divided into 20 parts, then 1 part is very short time period. And if an object moves faster than this time period, then you will not be able to see that object. Same thing is happening here. When it is rotated, then red color, blue color, green color, different color cannot be seen separately because they are moving very fast, and the total sum of the total effect can be seen, and sum of the effect, I mean to say total effect of this 7 different colored light is white. It means white light contains 7 different colored light in it. That's why it appeared white. But sometimes a little grayish appearance is seen. This is because of the impure color which we use to paint on this disc. Because of impurity of the color, sometimes it appears a little gray, otherwise the Newton's disc appears white. It proves that white light is made up of 7 different colored light. Okay, this way we can prove by the use of Newton's color disc. Okay, why we have to remember this? Persistence of vision of our eye is 1/16th to 1/20th of a second. Okay, now after this, I want to tell you another experiment also which can be used to prove that actually the prism is not adding different color to white light. It was questioned at that time when prism was used for the dispersion of light. 7 different colored appeared, and there was a question whether the prism add the color to the white light or really white light is composed of 7 different colored light. This was questioned at that time, and that can be answered now also very clearly. When we pass white light from one of the prism like this, and another prism is taken just in front of it in such a way that it is inverted, then what happens? From the first surface of the first prism, dispersion takes place. I am showing just 2 rays of light because many rays of light, if drawn, it is a little difficult to show clearly. That's why 2 edges are drawn here, red light and violet light. This is dispersion, and when light comes out from this prism, because of the dispersion, the separation increases in second surface because of refraction is followed by dispersion. And when it enters into second prism, then they recombine with each other and again white light comes out. It proves that actually prism is not adding any color to white light. Because at that time this was a great question for the scientists that probably prism is adding different colored light to white light. That's why 7 different colored light appeared. It was later proved that no, this is wrong. Actually white light contains 7 different colored light. It can be proved easily with the help of these 2 prisms which are placed one after another. One is in inverted condition. Once the dispersion appeared, and second time the same dispersed light recombined to form white light. It proves that white light is made up of 7 different colored light. Now one question, why dispersion occurs in the prism, but why not in the glass slab? We are using glass slab for the refraction of light. We did a lot of experiment related to glass slab in previous class also, but why dispersion occurs in prism? Why not in glass slab? I want to describe this with the help of a diagram. This is prism. When light enters into the prism this way, then dispersion takes place at this surface. This way light splits up into 7 different colored light. And when this dispersed light comes out from this surface, then they separate a little more than the previous because the refraction takes place on this surface. This way dispersion takes place, which can be understood nicely if we take a screen. These 2 surfaces are not parallel to each other. This is normal and light bent towards normal in this surface. When it comes out from the glass, light is traveling from denser to rarer medium. That's why all these light rays bends away from normal. These 2 surfaces are not parallel. That's why dispersion occurs here. But in case of this glass slab, what happens in glass slab? When light enters from one of the surface like this, then it disperses inside the glass slab this way and separates into 7 different colors. But when it comes out from another surface which is parallel to the previous surface, first surface, this bent light again bends in opposite direction. Here it is towards the normal, here away from the normal. Since two surfaces are parallel to each other, they recombine with each other and again white light forms. Again white light forms. This way actually the dispersion cannot be seen in case of this glass slab, but the dispersion can be seen in this prism. Dispersion can be seen in prism, not in glass slab, because recombination of light forms again white light. Okay, now I want to tell you about the rainbow. Rainbow is actually one of the effect of dispersion of light. I want to show with the diagram. Look at this rainbow. A man is very happy sitting in front of the rainbow in the middle. And have you noticed this? Here we have one rainbow, and just behind this at a little more height there is another rainbow also. This is another rainbow which is faint in color. Look at this. Its color is faint, but this is distinct rainbow, isn't it? In this rainbow, red color appeared at upper edge, but in this rainbow which formed at greater height, red colored light appeared at the lower edge. This is actually primary rainbow, this is secondary rainbow. Later I will tell you about this, but what is rainbow? We can say this way, rainbow is a colorful arc-like structure which appears in the sky due to the dispersion, total internal reflection and refraction of light by the droplets of water present in the air. Very interesting, a little heavy type of expression, isn't it? Let's have a little explanation. When rainfall occurs, after the rainfall, the atmosphere is full of water droplets. And if there is sun in the sky, then sunlight enters into this water of droplets and the dispersion of sunlight takes place. And dispersion produces 7 different colored light, and that is actually the rainbow. For this, there are 3 processes which occurs one after another in the droplets of water. First, dispersion. Second, total internal reflection. And third, refraction. After the successive these processes, when light comes out, then we will be able to see the rainbow in the sky. Now, let's have a nice understanding about the same. Let's say this is primary rainbow and this is a droplet of water. When light enters from one of the side, this way, this is white light. Now dispersion takes place at this point. And dispersed light goes to another surface. I am drawing 2 rays of light only, which is present at the edge of this 7 colored light, that is red and violet. We are not drawing all the rays of light. It is difficult to show all the rays of light properly from the beginning to the end. That's why only 2 rays of light is taken. Exactly, there are 7 different rays of light, which is told just before this. Now, it is reflected back by now this surface. Now, total internal reflection takes place in this surface because light is traveling from denser medium water to rarer medium air, and angle of incidence is greater than critical angle. Critical angle for water is 49 degree, and this angle of incidence is greater than critical angle. That's why instead of refraction, it reflects back in the same denser medium, in the same droplets, and reaches to this surface. And now at this surface, the simple refraction takes place because light is now traveling from denser medium water droplets to the rarer medium air, and that's why it bends away from normal, and this way it comes out. Now white light entered into the droplets, but when it came out from this droplet, it is now divided into 7 different colored light. And this 7 different colored light, when comes to our eye, then we will be able to see the rainbow. Now in first surface dispersion occurred, and in second surface what happened? This total internal reflection occurred, and in third surface just refraction occurs. That's why rainbow can be seen when the dispersion, total internal reflection and refraction takes place in the droplets of water. Okay, now let's have secondary rainbow. In case of secondary rainbow, when light enters, actually this secondary rainbow can be seen at greater height. If this droplet of water is at very height, then when light enters into it from the lower side of the droplet, then dispersion takes place from this surface, and when it strikes the opposite surface, then at this time total internal reflection takes place because angle of incidence is greater than critical angle. Now it is strike at this surface again, at this place also total internal reflection takes place because this angle of incidence is greater than critical angle, and when it comes out from the droplet, it is entering from denser to rarer medium. That's why bends away from normal, and this way it comes out. In this case, what happened? At first dispersion occurred, and then total internal reflection occurred, and then total internal reflection again occurred, and at last refraction occurred. Because of dispersion and 2 successive total internal reflection and then refraction, this secondary rainbow can be seen. It can be seen at greater height, and in this rainbow, violet colored light appears at the top, I mean to say upper edge, and red colored light appears at the lower edge. Okay, now after all this discussion, let's have a question. Without the question, we cannot say that the subject matter is understood. This is one of the method of evaluation. I made a question which is a little brainstorming type. A statement is given here. The process of splitting up of white sunlight into 7 different colored light is called dispersion of light. Is this statement true? Just think about this. I am giving you time to think about this. I'll tell you if you cannot answer this question. I'll answer all these. Now, one argument is added on it. In this process, the colored light having more wavelength bends more. Is it correct? Now, another argument, if this process is shown by using prism, refraction takes place on the first surface of the prism, but dispersion takes place in the opposite surface. Is it? After reading all these and after the analysis of this statement and arguments, you have to select one of the options from these 4. Now, let's start with this option, number 1. Whether this one is correct or not. Only statement is correct, is it? The process of splitting up of white sunlight into 7 different colored light is called dispersion of light. Yes, this is correct statement, isn't it? But here we have only statement is correct is written in first option. That's why we cannot say that this option is correct. Maybe argument 1 or argument 2 is also correct. At that time we have to change our decision. That's why this point is suspended. The first option is suspended. May be correct, may not be correct. We have to go through argument 1 and 2, then only we can decide. Okay, let's have second option. Statement and argument 1 are correct. Statement is correct, we know. Argument 1 is correct or not? In this process, the colored light having more wavelength bends more. If colored light has more wavelength, any one of the colored light having more wavelength bends more, is it? And look at this table again. The red colored light has long wavelength than any other colored light. Its wavelength is more. Yes, but red colored light is bending a little only here. Look at this. Red colored light has long wavelength, but it is bending a little. That's why this argument 1 is not correct. In this process, the colored light having more wavelength bends more, not more, more wavelength bends less. That's why this second option is incorrect. I want to drop it. Now third, statement and argument 2 are correct. Argument 2 is not seen. Let's see. If this process is shown by using prism, refraction takes place on the first surface of the prism, but dispersion takes place in the opposite surface. First surface, refraction is told, and second surface, opposite surface, dispersion is told. Is it? Look at this. Here, this first surface, dispersion takes place in first surface and refraction in second surface, but here what is written? In first surface refraction takes place and second surface dispersion takes place. This is incorrect argument. That's why we have to drop this number 3 also. Now what about number 4? Argument 1 and 2 are correct. These two arguments are incorrect. That's why number 4 is completely wrong. We have to come back to the first. Only statement is correct. This is the correct option among these 4. That's why we have to take it. Okay, let's have another question also. Find the correct and incorrect argument. Here we have some arguments. We have to decide which argument is correct, which one is incorrect. Number 1. In the process of dispersion of white sunlight, green colored light appears in the central part of the color band. What do you think? Correct or incorrect? I don't know now. I'll tell you later. Keep on thinking. Newton's color disc is painted with the color in the order of V, I, V, G, Y, O, R, each having equal sector. Is this correct? Just think about this. If you cannot, I'll answer all the question. Third, in primary rainbow, red colored light appears in the outer edge, but violet appears in the inner edge. Is it? Maybe, may not be. Just think. Now another. In the spectrum of dispersed light, the color band appears in the order of V, I, B, G, Y, O, R, VIBGYOR, from top to bottom. Is this correct? Think about this also. Now, for the formation of rainbow, 3 processes involves, that is dispersion, total internal reflection and refraction. This argument is correct or not? Looking at all these, I think till now you have decided which one is correct, which one is incorrect. Now I want to say the correct answer. Let's have first. In the process of dispersion of white sunlight, green colored light appears in the central part of the color band. Yes or no? Yes. Look at this. This color band is of V, I, B, G, Y, O, R, violet, indigo, blue, green, yellow, orange and red. Green is in the central part, isn't it? And this statement, or we can say this argument is correct, isn't it? Now next. Newton's color disc is painted with the color in the order of V, I, B, G, Y, O, R. Yes. Each having equal sector. Is it? No. This color should be painted in their presence. I mean to say the intensity of which colored light is greater in white light, that should take greater area. The sector, that sector should be greater. And the intensity of light, particular light is if less in white light, then we have to paint it on less sector of the Newton's color disc. That's why not equal sector is painted with all these color. Okay, this is incorrect. In primary rainbow, red colored light appears in the outer edge, but violet appears in the inner edge. Is it? In primary, red color light appears in the outer edge. Yes, this is correct. Now, In the spectrum of dispersed light, the color band appears in the order VIVGYOR, yes, from the top to bottom, is it? This last part is incorrect, not from top to bottom, bottom to the top. Violet lies at the bottom and red is at the top. That's why from the top to bottom is not correct. From bottom to the top, VIBGYOR order is maintained. Okay, this is incorrect. For the formation of rainbow, three processes involves, that is dispersion and total internal reflection and refraction, is it? Yes. Dispersion is followed by total internal reflection, and in case of secondary rainbow, total internal reflection occurs twice and then it is followed by refraction. Yes, this option is correct. Okay, this way we can find the correct argument and incorrect argument, we can separate them. Okay, what I discussed today, let's have a quick look. Short revision. Number one, I told you about the dispersion. It is the splitting up of white light into 7 different colored light is called dispersion. And secondly, what I told you, spectrum, the color band of the white light which appears after the dispersion this color band is called spectrum. And what is the reason of dispersion of light? I told you, white light contains 7 different colored light, and when it enters into the prism, the decrease of velocity of 7 different colored light is different because of the amount of decrease is different. That's why they separate from each other. This is the dispersion of light, region of dispersion of light. And we proved white light is made up of 7 different colored light by 2 different ways. One is with the help of Newton's color disc. Rotating the Newton's color disc, the appearance of the color disc was found white. It means the total effect of 7 different colored light is white. It proves white light is made up of 7 different colored light. And second, with the help of 2 prism also, we can prove that white light is made up of 7 different colored light. When it enters from one of the prism, it splits up into 7 different colored light. Again, when it comes out and enters into another prism, again they recombine to form white light. It proves that white light contains 7 different colored light. Now next, I told you about rainbow. Rainbow occurs because of this small droplets of water in the sky after the rainfall. When light enters into it, then 3 successive processes occurs over there: dispersion, total internal reflection and refraction. Because of these 3 successive processes, light disperses into 7 different colored light and appears as rainbow. Okay, next I told you about the primary rainbow. In this rainbow, red color appears at the upper edge, violet appears at the lower edge. In secondary rainbow, violet appears at the upper edge and red appears at the lower edge. Primary rainbow appears in less height, but secondary rainbow appears at greater height. All these are done in this class. Now I want to stop this class. We'll meet in another class with some another matter. Thank you.